Throughout households around the world, there is one food item which is regarded as a household staple. This would be beef, commonly consumed in the form of steaks, burgers, and hot dogs. The list goes on. However, as much as the everyday person enjoys these products, who doesn't enjoy a good old steak? The large scale consumption of beef comes with massive environmental consequences. In the last couple decades, the world started to take notice of the harmful effects of pollution on the planet. Ever since the age of industrialization, the methods of cattle rearing have greatly changed in order to match the ever growing demand of beef. This has unfortunately led to unethical cattle rearing practices. Millions of cows are forced to live in tiny enclosures where they are bred, slaughtered, and harvested to sustain the ever increasing unsustainable demand for beef. This exponential increase in beef consumption has led to an increase in the number of cattle being raised, which in turn has resulted in the global rise of carbon dioxide emissions. This is harmful because carbon dioxide is a greenhouse gas and is known to be one of the leading contributors towards global warming. The beef industry is one of the greatest contributors to the release of carbon dioxide into our atmosphere, and producing 1 kilogram of beef emits 60 kilograms of greenhouse gases. This is an issue because increased levels of carbon dioxide contributes towards global warming. This means that this has led and will continue to lead to increasing temperatures across the globe, affecting ecosystems, causing rising sea levels by melting the polar ice caps, and leading to the deterioration of our ozone layer, and can even lead to the extinction of certain species on this planet. In this presentation, we will be going over the benefits of decreasing your beef consumption gradually from 7 days a week all the way down to 0. This method can have many environmental benefits, ranging from slowing down the rate carbon dioxide builds up in the atmosphere, slowing the rise in global warming, and others. In order to reduce the effects of climate change through global warming, I propose that people should reduce the number of days per week of which they consume beef. As hard as this may sound, there is a product that will ease this transition. It is an eco-friendly and sustainable product called Beyond Meat. Through innovation and disruptive technology, the company Beyond Meat has developed a plant-based beefless product such as Beyond Burger. Mimicking the taste and texture of beef, this burger is not only a vegan replacement for your everyday beef, it is also disruptively sustainable, generating 90% less carbon dioxide than beef. As the consumption of beef is a major contributor towards global CO2 emissions, using data, we were able to extrapolate and predict what 2019 CO2 levels would have been like had people reduced their meat consumption by a certain number of days since 1959. Additionally, a model is also created to predict the CO2 levels in 2050 if no change is made to meat consumption versus if people reduce their meat consumption by 1 or more days. The average person will consume 8.4 kilograms of beef annually. This, of course, does not account for vegans and vegetarians. Total beef consumption in 2016 approximately hit almost 59 billion kilograms. For every kilogram of beef produced, 60 kilograms of CO2 is released into the atmosphere. The total amount of CO2 released due to beef consumption was approximately 3.5 trillion kilograms of CO2 annually. Using the current mass of the atmosphere to estimate the current contributions of CO2 emissions by the beef industry, we were able to estimate an addition of 0.642 parts per million annually. CO2 levels account for the significant contributions that beef consumption has had on CO2 concentrations. The National Aeronautics and Space Administration, otherwise known as NASA, was able to collect data on atmospheric CO2 concentrations from 1958 to 2019. Using the data collected from NASA, our analysts used Origin Pro's 2020 graphing software to plot a scatterplot graph of the data. Once the scatterplot graph had been plotted, Origin Pro 2020 was used to fit the data and determine the exponential equation. The data was fitted to an exponential graph model because it did not visually look like the general shapes of logarithmic, trigonometric, or polynomial graphs. However, once plotted, the scatterplot data clearly resembled the shape of an exponential curve. This is why an exponential curve was chosen. From the data displayed by Origin 2020 in the table above, we were able to model the equation of the graph. The equation is as follows, where 256 represents the atmospheric CO2 concentrations in 1958 and 57.839 times e raised to 0.01627 times x represents the predicted increase per year. After obtaining the equations that model CO2 concentrations in the atmosphere as a result of beef consumption, we can estimate the concentration of CO2 if beef consumption is cut or reduced to a certain number of days per week. In order to demonstrate this, we modified the model from earlier as seen in the equations below. So in order to calculate 5 days a week of beef consumption, the equation is C equals 256 plus 57.839 times e raised to 0.01627 times t minus 2/7 times 0.642 times t. To estimate the value of CO2 in the atmosphere if people ate meat just 5 days a week, we subtract 2/7 times 0.642 times t from the model because we are subtracting the impact of 2 days of beef consumption on CO2 released annually. According to the data in 1959, if everyone consuming beef decided to eat beef only 6 out of the 7 days a week, then there would be a change from 411.4 ppm to 405.8 ppm in 2019. If in 1959 people decided to eat beef only 5 out of the 7 days a week, there would be a change from 411 ppm to 400 ppm in 2019. If in 1959 people decided to only eat beef 0 out of the 7 days a week, then there would be a drastic change from 411 to 372 ppm in 2019. From the data, we can evidently see that if people in 1959 would have decided to eat beef only a certain number of days a week, then there would have been a sufficient decrease in the concentration of carbon dioxide today. Using data from the table, the following graph was plotted to visually demonstrate an estimation of what current atmospheric CO2 levels would look like if people had reduced their meat consumption by 1 to 7 days since 1959. Using Origin Pro, our analysts graphed the data from the table. The graphs displayed the real data showing how beef consumption has contributed towards CO2 concentrations in the atmosphere over the last 61 years. It also predicts what the 2019 CO2 levels would have looked like if people had reduced their consumption by 1 or more days per week since 1959. It is evident that total beef consumption is a major contributor in global carbon dioxide concentrations in the atmosphere. It is extremely important to consider the CO2 emissions released due to beef consumption because CO2 is a greenhouse gas. Greenhouse gases have the ability to absorb heat and can therefore cause a rise in global temperatures, leading to global warming. A decrease in the amount of beef consumed per week since 1959 would have led to a significant decrease in total carbon dioxide concentrations present today, and therefore a decrease in temperatures today. For instance, the graph demonstrates that if the global population in 1959 had reduced their beef consumption by 6 days on average, or in other words, if they only ate meat once a week, the current CO2 concentrations would be 377.866 ppm instead of the current 411.33 ppm. As you can see, by reducing the amount of beef consumed over 61 years, there is a significant difference to atmospheric CO2 concentrations. If that practice had been adopted in 1959, we could have seen a less of a rise in global temperatures today. Furthermore, as the data proves, adopting this practice would be extremely beneficial in decreasing and slowing down the rate of rising global temperatures, therefore also slowing down global warming. In order to show future effects of beef consumption, our analysts were able to formulate data to help predict the CO2 impact of beef consumption. The equation is as follows. If there is no changes in current beef consumption and people continue to consume beef 7 days a week, the equation C equals 411 plus 57.839 times E raised to 0.01627 times T models and predicts what the levels of CO2 could be in 2050 or 31 years from now if people did not change their current levels of consumption or if they reduced the number of times per week that they consumed beef. Starting with the 2019 CO2 concentration levels of 411 ppm, here are the equations that were used to model and plot the graph lines. In order to predict what the carbon dioxide concentration levels could be if people consumed beef 5 days a week, we had to come up with the equation C equals 411 plus 57.839 times E raised to 0.01627 times T minus 2 over 7 times 0.642 times T. This graph predicts CO2 concentration levels in 2050 if people do not change their current beef consumption habits. If society does not come to a consensus of reducing beef consumption, the levels in 2050 could be 506 ppm. This represents an increase of 95 ppm over a period of 31 years. However, if we look over the last 31 years from 1988 to 2019, there was an increase of 60 ppm. We did this by subtracting 411 by 351. This represents a 58.3% increase in the predicted rise of CO2 levels over the next 31 years when compared to the rise of CO2 levels in the last 31 years. If people reduce their weekly beef consumption habits by 1 day per week, the CO2 concentration levels in 2050 could be 503.94 ppm, 2 ppm lower than if they would have consumed beef 7 days a week. If people decide to completely avoid consuming beef, the carbon concentration levels in 2050 could be 486.86 ppm, 19.34 ppm lower than if they would have consumed beef 7 days a week. From observing these results, if people decide to adopt this practice of reducing weekly beef consumption, this would greatly aid in lowering the global carbon dioxide emissions, thereby slowing down global warming, as this is key in reducing the harmful effects of climate change, minimizing droughts, preserving natural crop cycles, preventing the extinction of certain species of animals, and bringing back the balance of Earth's natural ecosystem. Substituting to Beyond Meat will be one of the most important steps society can take in order to reduce CO2 concentrations building up in our atmosphere due to beef consumption. As of right now, there is no other product which mimics beef and at the same time is solely made out of plant-based products. As a spokesperson of Beyond Meat, I am proud to represent Beyond Burger, a beefless burger which does not use any animal products but mimics the texture and taste of beef. Not only being a vegan option, the environmental impact is second to none when compared to beef consumption. According to our analysts at Beyond Meat, Beyond Burger generates 90% less greenhouse gas emissions, requires 46% less energy, 99.5% less water, and 93% less land use. As you can see from the data, the impact of beef consumption in regards to the atmosphere is shocking. Sadly, society has not fully woken up to this problem. Yet, however, through your investment, we can aim to successfully market the brand to not only help the growth of Beyond Meat, but to promote the message of the harmful effects of global warming and the importance of slowing down its impacts. Hopefully, we can work together to reduce the carbon dioxide emissions and preserve life as we know it. Thank you for your attention. I hope we will be able to do great things together. And if you excuse me, I have a couple Beyond Burgers on the barbecue outside, so I'll see you later. While developing our model, due to the limited data available, there were certain limitations that are important to consider. The model does not take into account the other major contributors to global warming, such as the burning of fossil fuels or methane emissions from cows. The model does not take into account that people in 1958 generally ate less meat than people today. The model does not factor in rise in global populations over the last 61 years and over the next 31 years. However, in spite of these limitations, since the model took the CO2 contributions over the last 61 years with those limitations intact, the same model can be used to predict how future CO2 levels will be affected if human consumption of beef remains the same or if it is reduced by 1 or more days per week. Please find the research document for more information regarding calculations, deeper research, and sources used.